So if you recall, the last time we covered a lot of ground in terms of what was the core business of Netflix. And do you have any comments in that segment that we did the last time before I jump onto the further a little bit more technical details on how a given architecture that Netflix had in mind would be implemented? And that is something that I would like to ask you. Do you have any questions before I proceed in that direction?
No.
No. Okay. Good to know. So, what I'm trying to do is to avoid repeating myself in what I already have said in these videos. And so I recommend that you do watch these segments. There are segments like these, that I describe. And so I have tried to not repeat myself in terms of what is already contained in the videos because there is no point. Probably there will be some overlap. I might be saying some things in here in the videos that are may not be relevant given these videos are old. But that actually doesn't take away from the conceptual discussion. There are things that may have changed. For example, in one of the videos, I might have mentioned that Android is not supported as a platform on Netflix because that was the case at that time. And so the video might say that, but I hope you understand that Android is available now on Netflix as a Netflix app is available on Android, so you can get to use it. So that such discrepancies might arise because of the fact that these videos are a little old. I think they were created in 2013 or something like that. I don't exactly remember the date and when I created them. And so, having said, what I'm really trying to do is to not repeat myself in in our discussions. So, which basically boils down to asking you to please review the material. Uh, the videos are long, like 13 minutes long, so they're not really short and crisp. But bear with me and review these materials as you will find time whenever you do, which which means I'm not focusing on telling you what's already told in the videos, which means I'll discuss something completely different, related but not repeating. So, having said that, let's begin with the Amazon AWS architectural diagram that I think I had for the other day that we discussed these guys. Um, Opening up that picture for media and content sharing. And so this diagram, did you get a chance to review that? Let
Well,
me
I haven't, but I have seen this before, so
have you?
I have. When we're in the process of setting up our own architecture for Amazon for demonstrations and web pages, for live demos for clients and partners, we had Amazon explain it to us how they were going to do the media serving for us.
Sweet, sweet, sweet. So the description that I would like to give you in the context of media in general and media serving in specific, as in the case of Netflix, is what we are discussing. So we'll apply the concepts and principles that we are going to discuss in this sheet of paper that you have a link on your Slack chat as well, and then begin building on the concepts as to how would a large operation such as rendering movies on people's devices and wherever they are, wherever they live, in whichever geography they are, and a huge selection of movies that we have. And so that's what we want to discuss. By the way, before we jump onto this chart is a general purpose description of how one would construct something that I would call a YouTube. So in case of YouTube, I think most of you at least understand this concept of a user that uploads content to a YouTube as a content creator. And so what I'm going to do is open up this notepad and start writing on it as I describe my thoughts to you. And so in here, what I'm really saying is YouTube essentially the content creation happens from users. It is the users that are generating content. It's called user generated content, UGC. And that's what YouTube has built itself on top of, which basically means that the users are of at least two types of users. One of them is a creator user, and the other is a consumer user. Most of us fit in this segment right here. We just go to YouTube to watch, videos of cats and dogs and whatever else, right? That's what people do. And so consuming video content, so the content consumers, and these other people that are also, substantial in number, not as large as this, but still big enough, is lots and lots of people create their own videos and upload it. So it's uploading the videos that they create. And so if you think of these two types of users that a scenario such as YouTube has, or there are tons and tons of other such sites such as YouTube is, and these all cater to the idea of user generated content, where the user will create some content and upload it to the site. And then that same user might become a consumer and consume their own content, or there will be other people who will consume user generated content. So essentially, it is user generated content that gets distributed to the consumers, and somebody, or at least some portion of those consumers, are also creators. So they create and they upload, and they might also be consuming. Then, apart from these, this concept of an upload, there is a third concept also, which is what we used to do before we switched over from Hangout over to GoToMeeting. So when we were doing Hangout, we were doing that other thing, which is not really an upload, not consumption either, but something called streaming. So there's a third type of user which provides input in form of a stream. And so we were doing that part when we were using Google Hangouts. And the function in that was that you, or rather, I should say me, I was streaming my content, and that content was visible to you real time. And all of you are consuming that content. Some of you are actually participating by sharing your screen, so at those times you are streaming, and you are sending your screen out to other people. And so essentially, these stream sources, all of these, were transmitted real time, live, on the internet, on YouTube, with a front end of Google Plus. That's what you saw happening, and we were doing this already in as a streaming user. The other type of usage scenario, which is you have a user that creates a video and uploads it. And so that scenario is what we are doing right now, where we have a GoToMeeting happening, and at the end of the meeting, I convert the recording, and then that becomes my created item that I upload to YouTube. And then you see a link to YouTube. And so that's what you get in Slack chat or other places to see, watch, and consume later. That's the consumption role. So if you look back at this chart here, with that in mind, the user, which is this guy, this end user, what he's doing as a consumer of content, the person who is consuming the content, this guy. So three roles: streaming role, which is very, not too many people use. The second function is upload role, and the third function is view or consume. So the third function is very common, very popular, and this viewer or consumer will come and view the site. And so that is this user. The user comes along and tries to see the goes to the IP address corresponding to the service that you offer. So the viewer, I should say, the viewer will go to some www dot say netflix.com or some other site.com, and so they need to do that name to number mapping, and this mapping is done by some DNS server, and in case of Amazon it is the Route 53 server. So you see that reference right there. The very first thing, it will compare what is that endpoint, yourdomain.com, and what is the corresponding IP address to that. And so that's the first service you hit on Amazon. And you hit that service without knowing, because what happens is your DNS server, which can be either Google's server or some other server, like we had OpenDNS server or maybe Comcast server. They will all provide some DNS server. They in turn will refer to this authoritative record for your domain, which is here, and find out the corresponding IP address. And so in the case of Amazon, it will be the Route 53 servers getting hit. And that's the first service you will consume when you're trying to get to the appropriate address in the physical location wherever that cloud actually resides. And so to get to that IP address, you need to find the IP address, which you can do a domain name translation using Route 53. So that's very trivial and obvious. Next up, once you have the IP address, this end user will then identify a particular content that the user might have interest in. So for example, if you go to YouTube, and so you hit enter. The moment you hit enter, you're translating your name to number and you reach some YouTube video of Michael Jackson, for example, here. And so there we have Michael Jackson's video. And so here, if you look at this link and put that in some text buffer, you will find that it is mapping to, okay, the video started for no reason. Stop. And so this video, if you look at, it has this component, and the component is, the first is the protocol, second one is the actual domain name, which corresponds to some IP address somewhere, and then this instruction is to watch something, and that something happens to be a video number followed by a list and a list number. And so if you watch these items, this item actually corresponding to a video, which is the Michael Jackson video we are looking at right now. And so that is the number, and line number 7 is what you will see as the content. And the method will be to watch it. So that was the example of how the URL constructed will actually refer to that particular item in YouTube, which refers to this video called Remember the Time, Michael Jackson, that video, uploaded by this user called Michael Jackson Vivo. And so that user has uploaded it, and this content is available somewhere in CloudFront for you as an endpoint, as a consumer of this content. You as a user will get cached content, which is essentially a representation of the original file, which is stored somewhere, probably in some S3 bucket. And so translate that same idea to Netflix. What Netflix will do is, as you want to watch a particular movie, you will go to your endpoint and reach out to that endpoint where you are accessing some content, like this /content reference here. And the same content reference translates back to the watch an item here called video number, LEIFF0, whatever. And so that content is available somewhere, and it is probably very likely that many people are watching that video already. So it is more likely to be the case that it is available in your, oh, I closed it by mistake. So it is, huh? Amazon Web Services access denied. I'm accessing your files, not my files. Huh, interesting. How can it be access denied? I just opened it. No. Okay. Now it opens. So the cached content, which has the movie video that you want, might already be sitting in Amazon CloudFront already. And if it is that, if that's the case, it will be rendered to your device, which is your laptop, desktop, iPad, Android, whatever you have. That is going to be rendered with that video content that you might find readily accessible to you from CloudFront. And so you get it directly. If for some reason you don't have it, in that scenario, that video content is probably sitting in a bucket somewhere in Amazon. So what you would do is go find that bucket, and then in the bucket you will find the item, and that item will get cached into the CloudFront and then be delivered to you. So it will go, and when there is a miss of cache, it will retrieve the data when the cache is missing that item. So when this cache does not have the CloudFront cache, when that particular video is not available, it will go grab it from that original source, which happens to be this S3 bucket. And that essentially is the paradigm of watching. So when you have a particular content, then you go grab it from the bucket where it might exist, and you grab it and play it. That's the common typical scenario of a user trying to view something that is available in the view case. So Netflix users trying to watch something, they will get rendered whatever they want trying to watch through some content delivery network. In case of Netflix, they're using Amazon services, so it will be CloudFront in whichever geography you have. So it will get rendered to your device. That particular movie will show up based on your location and your CloudFront endpoint entry. So that becomes the scenario of a viewer. Now let us also understand the other scenario, which is a content creator, meaning a person who has a video. So like you will have these user generated content. So you have this user that generates some content here and has a video to upload because they use their iPhone to create a little video of their dog. So you have a dog video here, and you want to now upload that dog video over. And so the scenario will be the upload scenario. And so let us study that scenario also. It will be the same user again, or could be a different person, again looking up the IP address corresponding to the Route 53 DNS entry. But this time, what they want to do is actually provide their content in form of their own content that they want to upload into the service that you have. So like YouTube, for example, or other services like this are Daily Motion is another company that is a French company that provides YouTube like services. And so here you get to upload a video very similar to what you have in YouTube. And so you go click the upload button, and you need to have an account there before you upload. And so they will, in this scenario, what you're looking at is that they want to identify you. And the identification is that some kind of a login and password method, similar to this guy here, Michael Jackson Vivo. And so that is a user, probably a company user that is also verified. And so it's a bigger user. It's an established brand that has licenses to play these videos. And so they have uploaded through their account, Michael Jackson Vivo, and they have logged in. So if you refer back to that same story here, into this in this sheet of diagram, you will see that this particular user needs to be authenticated as that particular entity, Michael Jackson Vivo. Similarly, in Dailymotion, they are expecting you when you try to upload. If you just want to watch this video, they will let you watch it, no problem, without even asking you to sign on. And they will force you to see an advertisement like they're doing right now, but that's a different topic. But if you just want to watch a particular video, they don't require you to sign on. But if you're trying to upload a video, they need to know who you are, which makes you sign on. And so that implementation also needs another service. And so if you look at the same scenario here, you need to have another method where you need to identify where the user is coming from, who the login is, and who the person is, where its location is, what type of access credentials do they have, do they have permissions to upload movies or not. And if so, they will allow you to then upload your movie or your video that you want to have, your dog video that you want to send over, and then put that in a bucket. And then that particular user who's uploading a video goes away, and they may come back again as a person who wants to watch their own videos. And so that role or the function of that user changes from a person who's uploading to a person who's going to watch his or her own upload of the dog video. And that's what you will see, these roles changing over. And that's a common scenario with any type of YouTube or Dailymotion cases where you have a consumer as well as a creator role shuffled between. The same person might take this role versus that role, and it might happen all over the case. Whereas in the case of Netflix, you will typically not have the upload role. The upload role in dog videos don't exist in Netflix. In Netflix, there has to be somebody who's uploading, right? So who would that be? Somebody has to upload, and then people can view all day long and binge watch. But who's uploading these videos? Somebody has to upload it onto the netflix.com servers somewhere along the way. And so who would that be? Who's going to upload? And then you can all binge watch. So who are these people, and what are they doing? What are they uploading?
They can be anyone.
And they have to be Netflix employees.
Well, Netflix associated people, but they can be anyone that's has an account with Netflix to upload.
Correct. Yeah, absolutely. You have to have a entity relationship with this company, and you need to be responsible for that company's output. And so what typically happens is people who get licenses from movie companies, license to movie number, movie say XYZ movie that you have, or a new movie that comes up, or the new movie Spy that's coming up, right? So let's say Spy movie. The Spy movie is now going to be available, so you need to get the license to access that original movie itself. And that original movie file will probably be a raw file that is going to be very big. And so you don't want to necessarily send this raw file straight to the user because the user cannot play it. So you want to upload this big raw file for that Spy movie, for example, onto internal servers in Netflix and run through that process of what I described the other day was, convert that raw file into some kind of a format that fits every device that you know. So you have to convert for Xbox, for iPad, for Android, and all the varieties that for PC, for Mac, for every codec, every form factor, every resolution type, every frame rate. Like, you have to worry about FPS. This may be, higher FPS, maybe 96 frames per second or 120, 128 FPS. We don't know what frame rate they shoot at. We don't know exact resolutions they are, but the claim is that they sometimes have as high as IMAX resolutions, which can mean 18,000 progressive lines like this, 18,000 lines, which can be a very big format. And so you have to convert that format down to a resolution that you want for the target user. And so that entire process needs a collection of applications and servers in the cloud that will be responsible for encoding. And so this encoding, you get the raw file and then you encode it into a variety of different formats targeted towards the endpoint. Towards the endpoint meaning the iPad, the iPhone, or the Android, or whatever, Xbox, Nintendo, whatever target device you have to target these and do that encoding process. So if you try to illustrate this idea of what would it take to begin, so that's the first step. Very first step you have is that internal Netflix user has to upload it. For somebody else to be able to binge watch, they need to have this thing going in so that other people can then watch. And so that process is not trivial. It is not simple. You have to actually do encoding. So now help me understand what would it take to put together a cloud architecture that will enable some kind of a system of automatic encoding in the cloud. So encoding essentially, as you know, what it means is you have to run this software FFmpeg and give it some parameters so that it will generate an output file based on the input file that you already have from the movie studio. The input is the raw file, and you give it to FFmpeg, this software. It will produce an output file which will be a targeted output for every form factor, every device, every resolution you need ever in your organization, so that your users are all happy. And so that happiness will come from the fact that, hey, the movie played, and so this is the new movie called Spy coming out. And so what would you now do from an encoding perspective? If you are Netflix, what would be the case? What would you actually put together in the cloud infrastructure to pull this thing off? Just the encoding part. All we want to do is run FFmpeg and give it an input file called the raw file, and the output is for every different format. You have to run FFmpeg once, twice, thrice, as many times as there are devices or device types. And then you keep running FFmpeg, raw input, and some output. And so, you know, if you recall, the FFmpeg syntax is something like this. Chrome, where is my Google Chrome? There it is. And so here is Chrome, and here is FFmpeg, and the syntax is simple. You know, it is FFmpeg, input file, output file. Bingo. And so you have to run this command and prepare the output pretty much for every target device. What does that boil down to? Is what I'm asking you is to help me understand what would it take for us to, as a Netflix employee, you know, take that raw file and provide that as input and produce output for iPad and say output for iPhone, and keep doing until you finish all your target devices. So if you want to run this, what would you put together in form of some blueprint that you want to create and put together in your own cloud or in Amazon cloud for Netflix? What would you do if you want to run something like this? You know, run these commands. Essentially, that's what really happens. And so that's what you will see when you know, like at the end of this session, what I will be doing is I'll be running this application called GoToMeeting Video Converter. And that video converter converts raw files that GoToMeeting captures into MP4 format for YouTube. And then there are other conversions that YouTube will do for you for your target devices that I don't have to worry about. But at least I need to do this conversion for YouTube to be able to digest what I'm giving them. And so you can see that in RAW. If I open up my Finder, I can show you what this thing is actually creating right now as we speak. As we speak, you will find that
Probably have a graphical process unit to convert all of these parts.
yes, indeed. Absolutely, sir. And so you're right. GP or graphical oriented machines, you will be useful. So if you look at this documents and recordings, you will find that this TEMPAV function, that is where the raw videos and audios are stored right now as we are recording. And so here the temp files is where it is saving. This GoToMeeting software is saving them. And so once that meeting finishes, that I need to convert them into the formats that are available here that you see MP4 outputs. These are the outputs that I eventually end up sending to YouTube once I'm done converting them. So that conversion step is for GoToMeeting is this. But for these things to happen from a Netflix perspective, you need to make sure that you are indeed setting up an infrastructure that caters to the need that you have for your application. So the critical thing I'm trying to bring to your attention is that you have this dashboard, right? And in that dashboard, you will have to find machines that are most relevant to your use case. So in this example, the use case becomes something like we need to process videos. Okay, what does that mean? What's the characteristic of the application that is running there? So the characteristic is CPU intensive, graphic intensive. So we need to potentially find machines that will do what we want it to do. What does that mean? We'll go launch instances and try to find out what types of AMIs will we need. So let's say select. And so we have these multiple different types of machines available out there, right? And so we need to find out which instance types will be the most relevant. Micro, probably not. And so let's see, rule out micro. Okay, what about general purpose? Probably that's probably might work. We don't know. We'll find out. We'll say GPU instances is very likely the case. And so there are these two answers here. If we have a big movie collection already, we might want to go see whether this will work. And this is classically a game that we need to understand that it in your gut you might find that a G2 8 extra large is probably the right instance type, but sometimes the gut may be wrong. And so the idea becomes that this instance type may not be the right one for the job. And so we have to experiment a little bit because these things are not set in stone. Sometimes we want to see that it is probably the compute optimized this solution might be a better solution. So let's see if the no, sorry if let us find out if this solution works out better or not. So comparing these two is what I would actually begin, and I will begin comparing. So set up first thing first. Let's compare the basic prices. Because everything we do has a cost to it. So find out the pricing for these guys, and so here it is 4x more GPU power. And what's the pricing? Okay, come on, tell me the price, please. Go back. And so I'll begin studying the pricing of this type, which is in my case the price with G2 8 extra large. Okay, G2 8 extra large. So G2 is here. And G2 8 extra large is how much? Where is the price? Okay, come on. G2 pricing. It doesn't tell you what you want. And so Linux pricing data loading. Okay, there we have it. And so now we were able to see the G2 pricing, and it happens to be, okay, we got it. And so the pricing is here. Understood. Let's see the other one, which is the right one. Because the right sizing is very important in this game. Otherwise, you will end up spending more money than you would otherwise want. So here is another on-demand hourly price. The price is 168. So here, cool, we got it. Now, given this, let us also compare, while we are at it, compare the actual machine type. What do we get? And then we run some sample load. In terms of what we want to run is that, we are getting a 32 gigs of CPU and 60 gigs of RAM. So that's what we are getting, which is C3 8 extra large. Whereas in this example, what are we getting in graphic machines is kind of sort of similar compared to this, except these two are kind of sort of similar, except we know that they are graphically oriented GPUs. And so the pricing, therefore, is about $1 more. You can already tell by just the looks. The space here is a little bit more, but yeah, we can deal with the space problem. Probably space is not that big an issue in the case of processing. So that's how you begin studying about what do you really need for an application type. And you would actually run an example workload on both the machine types and see how much time does it take to finish the job. And then you can potentially also identify whether is this C3 8 extra large an overkill, or can we get by with a G2 2 extra large. And that trade-off is something that you have to really take into account. Can we get by with this for 65 cents? Is the right question to ask in terms of, if you have that kind of a case in mind, then 65 cents probably more appropriate. If it works out that it still takes a reasonable amount of time, but you're done by the time you really wanted to be done, so it might make sense to be cheaper than to go and spend more money. And so that trade-off decision has to be made on a case-by-case basis, always, every single time. However, there is one more key characteristic that is corresponding to this job, which is the encoding job. And that is there is something unique about this encoding thing. And that is what I'm trying to tease out from you guys as to what is unique in encoding. That is, and of course, GPU consumption is important, and you already pointed that out. There is something else that is important and kind of different than any other process in Netflix, in which the other processes will involve basically rendering that video to the user. So once your encoding is done, the other part, broadly speaking, is okay. Show me. Show to the user. What do you got? Show me your video, and that's the other part, the other major part. So get this. If you look at top level, acquire the movie, encode it, and then render it. Acquire the license, encode the movie, and render it to the user. That's the broad 3 steps that you really have to do in Netflix, and do it really, really well. Now, there is something different about this that compared to this action, and that difference is what I'm trying to tease out. In that, what I'm really trying to say is there is this user involved, and there is no user involved here. What does that really? How does that impact this operation versus this operation? So if encoding fails for some reason, is the user directly impacted? Is the question to think about. What's the user impact of acquisition, encoding, and rendering. If the rendering fails, what's the user impact? If encoding fails, what's the user impact? If the acquisition fails, meaning it's a business transaction. So a business transaction meaning you try to negotiate a license from the spy movie creator, and they said no, we will not license it, and so that is a failure of acquisition of license. And so this no saying that spy movie, sorry Netflix, I will not give it to you, and so that's a fail. And so there is an impact to the end user, of course, that you will not have the movie. But is that impact immediate? Or can you renegotiate and get to pass? Is the way to think about in the acquisition side. What about the encoding side? What happens if the encoding fails? You re-encode, right?
Right.
Yeah.
So are you getting towards like checksums, ND5s, or something like that?
Yes, that is of course a given. Everything you do has to be checked. No doubt about that. No, there's no doubt about that at all. Now, having here in the case of if rendering fails, is there a re-render possible?
So let me go back to encoding. That it's not in a sense of a full transition of steps. I mean, like the rendering is different from the encoding. If the encoding fails, I mean the user's still not gonna know because
Exactly.
that.
Exactly. It is a batch job. User will not notice it right away, even if encoding fails. No problem. It is a batch job. But if you try failing the rendering part, you have the users complaining right away. There is no such thing as re-render. You just have to deal with the customer. They will start crying out loud, and that becomes a problem. So you cannot fail here. In a batch job, which is happening maybe let's say, a spy movie, for example, right? Spy. It rolls out whenever it does. So let's fictitious date I'm putting in, like totally made up date, August. I think it is sooner, but I'm just saying August 1. And so that's the release date when users will watch. And so we have a license now. So we acquired a license. Good. Now we need to have this time window of June, July, full 2 months for encoding and making sure all other things are in good place. So we need to encode that particular movie and make it available in these 2 months. And so we try it one day and it doesn't work. Is the user impacted? Not at all. You try it again and try it again until it works. And then you're good. So this encoding part is a batch job. This is a real-time job. So there are economic implications of something being a batch operation versus instantaneous viewing operation. So the fact that this viewing is right here, right now, versus encoding is not really right here, right now. It is a batch job. You can do it overnight. And when you are in that situation, when you can do something in a batch, there is an economic implication to it. And the implication is that you can get away with a cheaper price because you're not time critical or not too much time critical. What does that mean? That you're in batch mode, that you need to understand that in case of this company we are talking about, Amazon, they have three types of pricing models. Do you know those three types?
Um,
You know this one. You used it all along. We just
Mint,
saw one of those. This is the on-demand pricing.
Right.
And this second one is called eBay style pricing, where you bid.
Okay.
And the third one is contract pricing.
Right. That's the monthly subscription, perhaps.
Yeah, it's basically upfront. You pay upfront.
Okay.
So you basically either pay upfront or you commit. So you commit that I will keep on using it for 3 years. I promise. So this commitment for say 3 years or 2 years or 1 year, whatever commitment you put in, and then you basically either pay upfront or put in a commitment. And if you're committed to using a machine for so long, beautiful, the price goes down. If you are on demand, the price is fixed, flat. That's what you will see here. Here, these are on-demand prices. All the prices you see in this section here, sorry, on the left, on the right section here and here, they are all on-demand prices. Meaning you run a T2 micro, you expect to pay 1 cent 3, 1.3 cents. And if you run a C3 8 extra large, you expect to pay $1.68 per hour. That's what we saw. And so these pricing numbers are what are called the on-demand pricing. But the second pricing method is very interesting. I call it the eBay style. There is a name for that called spot pricing. And so the actual name Amazon likes to use is the spot pricing. I call it the eBay pricing because it involves bidding. And so let us now take a look at example and go here and go here and go create a machine. But this time, instead of creating a machine of a size that I want and say I want M3 medium, let's see, what's the M3 medium pricing here? M3 medium pricing is 7 cents per hour. Okay, note that, 7 cents.
Mm-hmm.
M3 medium. Okay. Now I want M3 medium, but I'm not ready to spend 7 cents. And I don't care if the machine goes away. So what I do? I request spot instances, spot pricing. And you will notice very funny pricing here. You see that funny pricing already?
Yeah.
Yeah, it's crazy pricing. Let's see.
What the hell?
Yeah, it is like less than it's 1 cent right now here.
I'd be suspicious about the disk that's sitting on.
Not really. You don't have to worry about it. And so here I'm going to see that thing exactly. So I'm going to begin again. I'm going to launch an instance. I have some running instances already. And so in the dashboard, I have some instances here. Some of them are running. And what I'm going to do is I'm going to use my own machine image. I have this image here. I'm going to take that machine image and launch it in M3 medium. And what I'm going to do is not pay 7 cents because I'm not in the mood of paying 7 cents. So I'm saying, you know what? I'm going to pay you 0.011, which is slightly above your asking price. These are spot prices. If you bid higher than these, you will get a machine. So what I'm going to do is bid a little bit higher than this, like here. That I'm basically telling them I'm going to pay you 1.1 cent, up to 1.1 cent. That's the maximum price. The maximum price I'm willing to pay when my instance is running is this. And then I add some storage and tag the instance, configure the security groups, select my security group. And I would like to get the security group that I want, which is select an existing group. Where is my groups? My groups, what happened to them? No, not this group. Cancel. I have tons of security groups here. Whatever happened? Oh, they are hiding. Okay. Yeah. So I'm going to go my instance again, grab the machine image that I want, and this machine image I want to say launch. And so please get M3 medium and request spot instances, and I want to pay you only that much, that 011, not this much, slightly above that number, and say here make my request persistent. So what I will do is I create my FFmpeg machines that will do this job for me, and I'll run it first in a regular scenario, in a on-demand machine, test it out thoroughly, and then when I'm ready, I will come here and say, give me a cheap machine. I really don't want to spend 7 cents because that's the spot that's the on-demand price. So if you'll notice that in this particular region, usually the pricing is very low, and also here. And here it is 7 cents. By the way, this is not 7 cents, this is 70 cents. That's
Hmm.
ridiculous. I thought it was 7 cents, it's 70 cents. So compare that, it's higher than on demand here. This is ridiculous. Why would anybody even go there like this? But I don't understand this. So just leave that one alone. This is the higher than on demand price. So like slightly higher, 001 higher. This is the exorbitantly high price. I don't want that. This is the cheaper one. So I'll get that. In here, I can even create availability zone groups and make sure that my request is valid from certain time if I want to, but I can keep my request valid all the time. I can even make my request persist. So if the market prices, this eBay prices go up and down, you can see that fluctuation also. And you can see the fluctuations of these pricing once I will show you, once I get to that screen. You can see that these prices actually go up and down depending on demand. And now we can here say that I want to launch in my VPC, put it in that subnet where I want to create a subnet, maybe launch it in US East 1E. It has to be matching the East zone because that's where the pricing matches to. And so launch it in the East subnet, US East 1E subnet, and everything else should be okay. Add some storage, tag the instance, and call it my EDX app E in the E region, configure security groups, and in here, select an existing group, and I'll create my existing application security group, and then I'm ready to launch. And when I do that, it will do launch a machine primarily if and only if these prices that you have asked for are higher than the spot price. So you remember our spot request that I currently do not have. But if you look at pricing history, you will find that I have had some spot requests already in the past, and I'm going to go look at M3 medium and look at the availability zone 1E. You will find that ridiculously low price machines here. In fact, at some point in time here, it is 009,392, and it changes over time. So if you go scroll up a 3 month period, suddenly you will see that there is a spike of 70 cents, and then back to low, and then spike again of 70 cents and back to low. And so here, spike again at this time back to a high as 45 cents, back to low. And so if you look at this pattern, what do you see is going on? What do you think is going on in that location with Amazon Virtual Private Cloud in 1E area here and over a 3 month period for M3 medium types? What do you think is going on?
There's some scaling going on, scaling up.
Uh, Not really. Not really. What Amazon is trying to do is what I call is um, let me give you a story before I describe it because it doesn't have a nice word for it. So if you have an airplane and an airplane is trying to fly from Seattle to Mumbai and the plane is about to leave in next 10 minutes and then there are these seats vacant, three of them, this spot here and that spot, three seats are vacant, then there are 50 passengers in wait list.
Yeah.
Sorry, not on wait list. There's just 50 passengers who
Stand by.
who are there, who they not really want to go, but they might want to. And so the price of a ticket to go to Mumbai is $2,000, and you are Emirates. And so what would you do? You know there are these three seats vacant, and the price is $2,000, and the price of peanuts is 10 cents. And so they have to spend peanuts and some cleaning, and cleaning will cost them say $10. So okay, $10, 10 cents for peanuts, they don't feed you anything else, and so the cost of one additional person to fill the seat is $10 or 10 cents. That's their cost. Now these people who might be out there, hey, do you want to go to Mumbai right now? There are three seats left, I'm going to give you a big discount. What should that discount be? That is what you see in Amazon.
Uh-huh.
So they have empty seats in the plane that is about to fly. The price of the plane ticket is $2,000. But the cost to run the extra seat, there are these three seats left. The cost to run this seat and let a person sit in here and here and here, cost per seat is only $10.10, not 2000. That's the sticker price.
Yes.
So that is what is going on in Amazon. Amazon is saying that, hey, you guys, you want to go to Mumbai? Come on in. Give me $20. I still make $9.90. I'll feed you peanuts and clean the toilet.
Yep.
What do you think? You still make this
Sure.
money. Should you take it?
Hell yeah.
Hell yeah. That's exactly what's going on in Amazon. Hell yeah. This is what it is.
Wow. Now that price that well, spot instance, you're not going to pay any more than that, right?
Correct? You'd set your higher price, whatever you want to pay, and then that's what you will pay.
Now, is there any risk in that? Because we know Amazon wants to make money. Jeff Bezos has to pay the shareholders.
Correct?
At 1.13 cents an hour, is that always going to be delivered to you, or are there going to be times where, sorry, we don't have the resources to receive that from you? You can see it going down again. We don't have the resource. So Amazon will always say, yep, our price will never be higher than that.
So what happens is, go back to this plane analogy here. You have the plane guy, the Emirates company. What they will do is, they have these plane is about to fly, and will they always give you a ticket for $20? I don't think so. They'll give you only if there are actually seats left that are otherwise going to go waste. It is like, the price of a ticket. Let's say, I'm going to draw a graph and time and price of a seat. The price right now, the plane flies at this time, right here. The plane flies. The price of the ticket is $2,000. What is the price here? Worthless. Its plane has flown away. It's worthless. It's gone. It's useless. You cannot even sell. What they're really doing is at this very last moment, they're dropping the price, boom, and collecting that tiny little margin.
Right.
And so they will be able to collect that margin if they actually have seats. If they don't have seats, to the fourth person, they'll say, sorry, no more seats.
And that used to be a neat way of traveling around the world. If you had a backpack at the airport ready to go, and then somebody has already paid for the cargo space for the shipping of the package, but airline rules say passenger has to accompany it. So suddenly you found yourself paying $100 to go to London instead of $2,000, and all you've got to do is carry the package. Of course, nowadays, do you want to carry that mystery package? But that's how FedEx and UPS used to make up for some of the shortfall. $2,000 to get this emergency package. Well, I can get $100 back because there's a guy in a backpack who'll pay that for the seat.
Yep.
So now I'm covered.
Makes sense. Makes sense. That's exactly what you see in the scenario. What I call eBay style pricing or spot pricing is what you just saw.
Reading.
Now that scenario is extremely useful when you are doing batch jobs.
Right.
When you have to do encoding, why would you pay 7 cents when you can get by paying 0011?
Mm-hmm.
Well, let me, I understand the plane scenario because there's, you know, the seat's going to be worthless once the plane departs. But from a machine point of view, the machine's there, it's sitting there, it's not going to go away. So I'm trying to figure out.
Okay, here is what happens. Here's what happens. Let me tell you how the machine goes away. So imagine this is a machine. And you know that the Amazon company sells it for this price
Yeah.
per hour. And so imagine a case when the machine is actually there, but there is no customer.
Oh, got it. It's not processing anything. Got it.
So when there is no customer, what do they do with the idle machine? Just give it energy and electricity and cooling and all that maintenance, and you keep doing that and still leave it with no customer? Or do you want to make
Okay.
money?
I see that point now. So getting back to Chris's question, can you lock that down at that price?
No,
Or is it
it goes
and
away.
you
Whenever Amazon feels like they want to give it to a real paying customer who's going to pay them the full price, they will kick you out.
so when do they kick you out? They give you a month or they give you a
No,
week or
no,
they just
just an hour.
disappears?
An hour. Anytime they find that there is a customer that wants and willing to pay them this money, they'll kick you out.
So when you showed that chart where it spiked, so all the people that were paying like a penny.
So let's go look at the chart again.
Like on May 8th, all those people got kicked off, right?
Yeah, so let's see here. And so now look at this May 16th, this price suddenly went up, boom, 70 cents. And so everybody got booted out who were doing a low price ride all along from this April month over through this May 16th. In fact, there is more granularity even underneath. Let's go deeper in 1 week segments and see that they are changing over time. So it's not really flat at less than, like, is it 9 cents? No, nine tenth of a cent, right? And so it's 9/10 of a cent all along, and then suddenly there is a low spike here. The low spike is
Yeah.
like 1 cent 5, right? 1.5 cents here. It's a low spike. It's not a high spike, but it's still a spike. And so if you're bidding 2 cents, you will ride along just fine. If you're
Oh,
if
I
you're
see.
bidding 1.25 cents, your machines will die at this date. If you bid a little high, say 2 cents, as opposed to this, you might
Yeah.
just ride fine and proceed and continue using your machines, and they'll keep on working. Let's look at a 1 month segment. So the spike he's here, it's a micro spike. It's not as big as this spike. This is like, okay, kick everybody out. And it's deliberately done by some pricing administrator. You kick everybody out, all the cheapos, kick them out. Boom, 70 cents. And they just clean up. And
Yeah.
that's done by some pricing administrator on Amazon side. They want to basically flush. So they arbitrarily shoot the amount high to kick everybody out. Similarly, in these regions, if you look at this region, this is
Whoa.
A, US East 1A example, you will see that they are arbitrarily keeping the number high, 60 cents or 62 cents, whatever. And they do that quite often because they are almost, keeping the region 1A almost always high numbers, except certain months. Like in this period from May 8th to May 24, it was not high, but almost all other times it is usually substantially high, like wicked high, higher than the on-demand price. On-demand price is 7 cents, like it is actually here in my where my mouse cursor is. That's where the on-demand price is. It's 7 cents. They arbitrarily bump it to 10 cents at the minimum because they want to keep that region empty of the cheapos. And similarly, they want to keep this region C empty of all the cheapos. See that?
Yep.
So this is their executive suite. They don't want cheapos here. They want cheapos to go here. Think about it. That's what they're doing. You can find some cheapos in B occasionally, and the price here at the moment is 11 cents, which is still higher than
Right.
your on-demand price of 7 cents.
This is
Well,
the biggest problem in the storage industry is that a lot of clients want to use the cloud. They want to use Amazon, they want to use Azure, etc. And then they're horrified at the pricing because one, they've got a machine that's got to be running 24 hours a day, and then they need elastic block storage, and they might need Glacier. And we had one client who had spot instance pricing, exactly what you're talking about. He had an extra 3 large storage optimized. He's paying $1.30 an hour. So he said no more than 90 cents. And literally 3 times a month, it's not working. It's failing. I wonder why.
so that's not his production area.
It may be his
I mean,
batch.
I could see the environment being more like, if it is production, you're running those batch jobs, like you said, who cares?
Yeah.
You just run it over again. But um, that would be more like maybe in a test region, a test environment, or maybe a development environment. I wouldn't
No, not
recommend
for
that in
production.
production.
No, not if you need something 24/7, 365.
Yeah,
That just wouldn't run.
yeah, exactly.
Yeah.
So the thing that this thing applies if you're doing some batch processing, right? You're doing some encoding work. It is by nature a batch operation. And if you're doing rendering of of videos to the end user, it is not a batch operation. You need to have 24/7 running all the time. Whereas this activity can be done in batch. What does that mean? Is that if you want a G2 8 extra large, like here we discussed, G2 8 extra large is $2.60 per hour. Okay, you get that. Now let us compare. What do we have here? Is G2 8 extra large pricing over the last 3 months. And if you scroll down to say 1 week, what do you see the pricing is? It is 30 cents. You beat that, 30 cents versus $2.60 per hour.
Yeah.
So why not? Why not? I get a G2 8 extra large machine for 30 cents per hour and 0.30 per hour and get by my way of doing batch operations all day long. And if the machine dies, who cares? I'll run it again. If the batch processing fails for some reason, okay, no matter, do it again. We have ample time. This is not time critical. And so such operations can be conveniently done instead of paying $2.60 for cents. Like here, 30 cents. In fact, we can go and check that out. And you can go here and say, I want to choose my machine image that I have here and say, run my image, this image, and say, launch a machine and give me a G2 8 extra large and configure the details, liquid spark instances, and I am going to pay how much? 38 cents.
39 cents.
39 cents, 38 cents. 40 cents, 70 cents. So by the way, some region is missing here for 1B is gone. It's not listed.
Yeah, that's interesting.
But yeah, if you really want to get a machine, I will go with 1C and quote them. I'm going to pay you 0.038. That's really being aggressive. That's very aggressive. And so instead, what I should do is look at the spot pricing history and go look at G2 8 extra large for the last week or so in all the zones. And so let's find out what's going on. What's the lowest zone here? The violet colored. So I'll go switch to the violet. And in there, I find that the pricing is whatever it is. Let's see, 1-day pricing. It has been in the range of 31 cents, 32 cents. It has crossed this peak of 35 cents. Let's go 7 days and figure out where the peaks are. The peaks happen to be at this point, which is 70 cents. So I'm going to, bid 80 cents. And that becomes a safe bet if I really want it for a long term. So I'm going to say, okay, give me for 80 cents. And I'll add some storage. And they will charge me only whatever the pricing is. They'll not charge me 80 cents because this is the maximum that I'm willing to pay. I will be charged the spot price, whatever the price is. So this is the price, that's what I will pay. And if for some reason they want to flush out all the cheapos, they will do that by jacking up the price and all our machines will be dead. And that's okay. We are not time critical in the batch operations. We can afford to redo it. And so this saving is substantial. If you have large number of machines running, doing batch operations, if you are able to handle that downtime a little bit, you can go cheaper. And this is considerable amount of saving right here, right? 60 cents and 30 or maybe 40 cents. Still quite a bit. Huge saving. Down to 4. 2.6 down to 0.40. Substantial saving right there. So you can absorb and keep those savings on your bottom line for identifying operations that are non-critical, non-time critical. So you have a rendering operation that is super critical and you don't want to go mess with this kind of a game. But in the other in the encoding game, you can totally do that. You can go and wait for the airlines to actually fly, and just before they fly, you show up and say, "Hey, I want to go to Mumbai," and they say, "Fine, $20," and you ride the plane. But on the other hand, you're willing to take the risk of driving back from the airport back to your home if there is no seat available for $20. You go home. You don't go to Mumbai. And you do that
Happen.
probably every single day. You go to the airport, find out if the plane is available, otherwise go back home, and you do that over the period of a month. Every day, you might actually find a ticket to go to Mumbai, $20. But on the other hand, if you're spending taxi fare from home to airport every day for last 30 days, you will actually spend this money. And so you have to worry about those aspects. Basically, what I'm saying is the economics involved in there is a word for it. The word is opportunity cost. So you need to worry about what else are you missing if you are not doing that processing for, say, transcoding or encoding. You're not happening. And if encoding is not happening, what are you really losing? And if the opportunity cost is low, you can probably take a bet and go this spot price route, and no problem. But if you have something else to lose, if there's nothing to lose, why not take a shot? And that's how batch operations are done. So anything that is batch mode, think about spot price. And similarly, the other story, which is where you have a customer, which is your end user, and they expect you to render the movie every single time, 24 by 7, whenever they feel like they should get it. You have to identify what are you really getting. And in that scenario, you will identify machines that will render for you. So you will have these some types of machines that you will deploy that will run your rendering applications. So for example, let me pull up that chart again here. This chart, there are these machines that are responsible for rendering the movie onto the end user's target device. Now those machine types will probably not be the ones that are intensive in your media encoding, but instead they're more in terms of rendering the item and delivering it to you. And so those machine types should not be spot. But then what should they be? Should they be on demand? Should you be paying 0.07 for a M3 medium? What should be the case? Uh, should be paying that much, or why not pay a 0.013 on spot? No, you cannot do spot because the end user will complain. So you cannot really go spot. Fine. What's the outcome? What's the alternative? What do we have? What can we do? How can we save money and still pull together an infrastructure that is not spot and not on demand either?
So this is when we're going to do a contract price or something by the month?
Exactly. So you enter a contract with Amazon or any provider, and you ask them to give me 30% discount. And so that is what this thing essentially is. If you look at the contract pricing, it is 30% discount commitment. So if you look at here, And these are also called reserved instances. By the way, contract instances, the right name that Amazon likes to use is reserved instances, not contract, but reserved. And the word they use for on demand is on demand. For contract instances, the word they use is reserved instances. And then you already saw the spot instances. So here, 30 reserved instances, they apparently give you up to 75% discount. Typically, you see a 30% discount, most likely. Now let us see. On a T2 Micro, if you pay on demand, you're paying 1.3 cents. Okay. If you're paying a contract, 1 year contract term, the pricing you will pay will be 0.009 cents. So 9/10 of a cent, this one. That's the pricing you will pay if you take a contract for 1 year and you tell Amazon, I will keep on using a T2 Micro for 1 full year, I promise. And I'll pay you this amount hourly. And that constitutes a saving of 31%. Beautiful. I'll take that. Similarly, if you take the same concept of over to a 3 year period, 3 year contract, your longer duration, your pricing goes a little bit down, but then they expect some upfront money. They want you to give them upfront. Apart from the commitment itself, going from 1 year to 3 year, they take some money upfront and drop the price even further. And so this you have to keep paying over a period of 3 years, 0.006, but you pay some upfront. And you overall on a period of 3 years, you get a 53% discount, which is also nice compared to this. And we are talking about like portions of a cent. But essentially, the idea is that you will probably have many machines, so the overall bill gets impacted considerably. Similarly, if you look at the same pricing structure, it kind of replicates on its own, pretty much same. You get partial upfront for a 1 year period. You pay this upfront $51, and the pricing on comparatively becomes discounted. So same with T2 small, T2 medium, M3 medium. The long-term pricing is substantially discounted. You see M3 medium 3 year term, 63% all upfront, 687. Pay them all upfront, use the machine for 3 years. Beautiful. As opposed to paying amount of 7 cents, you would pay an amount of, effectively speaking, an amount of less than, say, 3 cents. Roughly about 3 to 4 cents is what you would, about 3 cents is what you would go with a 3 year term with nothing upfront. So there is nothing upfront option not available for 3 year term. So they'll expect money from you upfront, which is still good in the long term if you know for sure that you're going to stick with your cloud provider and that you know that your end users will want to watch your machines anytime they feel like, and that you have to have your machines up and running all the time. I mean, all the time. There's no point in going on demand. It's better to go a contract. And the contract is called reserved instances. And that reserved pricing is kind of a nice thing to have. I think Jared just joined, right? Hi, Jared. And so that reserve
Hey,
pricing,
sorry, I'm a little
oh,
late.
no worries, I understand. So the reserve pricing is useful if you know for sure that you have to have machines up and running for your customers that would expect zero downtime. And so if you compare that with the analogy that I have put in place for you in this example, you see that the number of people hitting right now is very small. So in this example, I have a T2 medium and it is running on demand. There is no spot pricing here, and it is running with on-demand price because the price itself is so low that I don't care. You have a NAT machine running T2 micro and another machine running T2 micro, and that's pretty much the entirety of the machines that you see that is responsible for this site. Not this site, the this site.
Right.
So this site, what you see here, is what is actually running on that machine here, T2 medium. It needs to have 4 GB RAM, and it runs just fine. But that alone is not doing it. There is a load balancer involved. In that load balancer is one instance active, which is this one. Then we have in that load balancer, apart from that load balancer, we have a database, and this database is running. Where is that? Instances. Oh, there it is. So here, my MySQL instance running here, and so that one, and it is seems to be backing up. Finished database backup. Nice. Yeah. And so it is running, and that endpoint is is inside the VPC. It is not publicly accessible, so it's all hidden inside. And so that's what you see in this entity. Now, if as I plan to scale it, what would I do if I want to add more machines? So, for example, if I want to create more machines in the subnet that I have chosen for this guy is 1A. And so the availability zone is 1A here in my subnet that I see. It is 1A, right? Yeah, the subnet is what I was looking for. Yes, it is 1A based on this private IP address 11. That tells me it is running in 1A. Now, if I want to add more instances to supplement this machine, this EDX machine that runs this, so on that end, what I will do is I will add more instances. So launch an instance using my own images, which is this image, EDX image. Select, and then select M3 mediums, configure details to launch into that subnet called 1E, and I would select a spot instance, and there the prices went further down, 9.3 now. Just a few minutes ago it was 001, now it is 0093. So I'm going to go 0.018 and add storage, tag the instance, configure security group, choose an existing group, this one, and launch. Then when I do, you can watch what happens when you do a spot instance request. Have you done it yourself ever? A spot request?
No. No.
Do you want to see how it flows?
Yeah, let's see.
How it, did you say how it flows or how it blows?
Both. You'll see both. So
Okay.
what I'm doing is it will flow through. The request will be pending. You will create a spot instance request. It will then become in pending mode. Then somebody will evaluate it, and I think that somebody evaluation is all fictitious. It's mostly waiting for the price math to complete, and when the pricing math on Amazon side completes, then it will relinquish the hold and allow you to create a machine. So you will see that a machine will get created with my chosen image that I have already put in place, and in that image, an M3 machine will get started in the security group chosen that I have, with the instance details being that I need to be a spot request instance, and I'm going to pay them 1.8 cents as opposed to what they're asking is 009. I want it to be created in my subnet without a public IP address and some minimum storage and some tags. So I don't have tags. I should just add a tag here. and then I configure security groups and review and launch. So once I do that launching, let's launch it. So I'm going to launch it, just checking one more thing, spot instance, pricing, and I'm going to launch and select my key pair and say, okay, go launch it. So let's see what happens now. What you will see is that you still have no new running instances, but you have a spot request, and that request is open and it is pending evaluation, and the request is open. The request was something like, I'm going to give you maximum of 1.8 cents. I'm going to do this one time, and it is pending evaluation. It has been submitted for review and is pending evaluation. And what this evaluation will actually complete and most likely succeed, because the pricing history tells us that for Linux instances inside a VPC for a M3 medium for the day today in East Zone, our pricing has been low, and I have bid 0.18, not as low as this, which is 0.93. I have bid way higher, so I'm very likely to get it, very likely to get the machine available to me, and I can see that coming up any moment. This evaluation will complete, and once the evaluation completes, it will then automatically start my machine based on my image that I have chosen, and my images are already available here. That's the image I want to use, and so based on that image, a new instance will get created and show up here as soon as the spot request is approved. Now similarly, similar to that same scenario, this once the spot request is approved, it will show up a machine, and that is awesome. Now for the other existing machines that I have here, that I'm running, this machine T2 medium, this NAT machine, I need to run them all the time. So I think it makes sense for me, because I'm going to run them all the time, that it actually makes sense to ask for a reserved instance, which means that I can just convert my existing running instances, these two that I need to run all the time. I'm just converting them by buying a reserved instance and say I want to get a Linux of T2 micro type, and let's say put that in, what zone do I have? I think my NAT is in East A, and the other machine is also in East A. Okay, so I will go just like that, purchase reserved instances, and select Linux in VPC, T2 micro for a NAT box in availability zone 1A for a 1-year term, and default tenancy is the cheaper version, and any offering, meaning the marketplace here is that there are other people who might have purchased reserved instances can also sell their reserved instances away. So it's a marketplace. And here you can say that I want to pay all up front for the T2 micro, and then I will search. And so they tell me that for 12-month period, I can pay all up front $75, and that T2 micro becomes mine. So unlimited quantities available, all upfront pricing 75 cents. The effective daily rate, effective hourly rate becomes 0.009, which is very nice. And I can add to cart and check it out. So in my cart, I am supposed to be paying them $75 right now, given that I'm going to use that T2 micro as a NAT box all the time. And so I can then go change over to Linux in VPC, and instead of T2 micro, go T2 medium in the same area, same everything else, and then search. And here I find that I need to pay upfront $302 for all upfront cost of a T2 medium, which is the other box that I seem to run. So I can go all upfront, add to cart, and view cart. And I think I added twice by mistake, so I'm going to shut it down to one. add more to cart, let's say view cart. And so now I have a bill of 377 that I can spend and get these two machines all loaded up. And these are the prices that I get to pay. If I'm paying all upfront pricing for a 12-month period, that is probably a nice one. In addition to that, I need to also worry about my database. So see if I can apply this to my database, Windows with SQL Server Web. No, that is not the one I want. And so I think what I'm trying to find out is if there is a way to get my load balancer also, which is going to be running all the time, and also my database instance, which is going to be running all the time. Can I also apply the reserved instance pricing to those databases? And once I do that, that corresponds to the discussion we are having, which is, hold on, which is here, which is my customers that really need my video rendering to happen all the time. They need this video to be rendering anytime they want, which means that I need to have a dedicated infrastructure. So I can go, the model of usage would be reserved instances is best suited, reserved here. And for encoding, the better suited option is not reserved, but the spot pricing instances. They are probably well suited for this game, for the encoding part. And the rendering part, of course, we get reserved machines and then put the infrastructure in place, get 30 to 50% discount from Amazon. And of course, we always have the on-demand option, which is always available. Anytime you need a machine, you can get the on-demand price and pay that, and you get the machine. That's a possibility, always exists, because the cloud is supposed to be infinite. It's an illusion of infinity. And the cloud is, as they're trying to claim, it's an illusion of infinity, like we covered the very first day. So now you recall that I have actually placed a spot request. And so that spot request is now approved and is fulfilled. So my spot request is now fulfilled, which means I should have a machine already. And so here are 4 running instances. And this is the spot machine. So I'm going to label it EDXE. And that machine is M3 medium. It is running my private IP. So I have a private IP here. And a public DNS is missing, which is exactly what I want. Now what I will do is go back to the dashboard and go to my load balancer, and I said, you know what, please take my load balance, my new machine, add it to the load balancer, please, boom. And it adds it. It is still out of service, but we can put that in service by making a change in Route 53 and letting that computer be aware that I have it. So meaning I'm going to associate an IP address corresponding to it. And so this IP address needs to change and then save. And then I need to run a script for that machine to come online and become available in my load balancer set. Right now, both the machines are in service, as you see here, but one of them is a little bit out of date. This machine that I just created, a spot instance, is out of date. I need to update it, although it is in service, but that's not how I want to run. And so I want to make sure that I clean it up. And I can clean it up by running a script on my side on terminal to make sure that that particular machine is up to date. And when it is up to date, only then I want to put that in the load balancer, not right now. So I'm going to eject it out of the load balancer right now and make sure that I don't keep that in the party. And so that's how spot requests are handled. And at any time when you feel like you don't want the machine anymore, even though they have fulfilled your spot request and it is now available to you, what you can do is just, cancel your spot request and go to the instances and kill that machine just like this, instance state terminate, and the machine goes away, just like that. I'm going to terminate that EDXE machine and say go bye-bye, and it dies. And it dies, and you can see in the spot request instance here that your spot request has been cancelled. And there we have the machine showing its state. Why was it cancelled? Even though the life cycle was spot, you cancelled it, the user cancelled it, user initiated a shutdown, client user initiated shutdown. That's the state transition mentioned here. And yes, I will get a bill for 0093. And so that is the price that was corresponding to the spot request that I had. And so that bill will be added to my collection. But the spot request process, as you saw, is how it rolls, which is you set a maximum price and you can then select whatever you want, and you can see the history, and based on history you can predict appropriate price for a machine type that you want. Like I chose this, and then I chose this region, and that's what I got. And so the lowest price was 009293, and so that's what we are getting the bill for. So does that give you a good perspective on how you actually go and select a machine in real life for a given type of usage, whether it is a batch use or a real-time use 24/7. If it is 24/7, you go this. If it is batch, go this way. If it is, just casual ad hoc. If it is ad hoc, you go on-demand pricing. So you go on-demand pricing when it is ad hoc, when you know for sure that it's going to run 24/7 by 365, or at least 365. You got a 1 year commitment, and if you know that it's a batch process, then you go spot pricing and fishing for the bottom.
Mm-hmm.
So what do you take from this discussion?
Very interesting. I think we need to have a new terminology called, you're calling cheapos. We need to have it called cheaple, like cheap people. Cheaple.
Cheaple.
Everybody's heard of sheeple, which is cheap people. So now we have cheaple.
Cheaple. I like the word. I might use it. Cheaple. Actually, cheaples are practical people. They're practical people, meaning they really think about what makes sense to, if it is not relevant to the end usage, then why waste that money ridiculously? And that's how I think. That's how I run everything I do. And I think it is the most rational way of working in terms of getting things done. Why would I waste money on something that is available for a spot price if I know that I need it only for a certain amount of time? So I just take it and then get rid of it when I don't need it, or maybe it dies on its own. I don't care because it's a batch process. I can handle it, no problem, right? So similar to that diagram that we just saw in here in this diagram, there are many such charts available here. By the way, there is a huge collection, and this I think is one of the very nicely documented best practices collected, put together from the perspective of Amazon. So it's strictly Amazon focused, but I would like us to actually study each one of these. And in fact, what I would suggest is that you take two of these examples. Like I just went over and illustrated and demonstrated how this thing works. So I haven't completed that part. I just went through this segment of how the end user comes in, uploads their content, where the content actually gets rendered to the end user, or where the content that end user is saying in when it's trying to upload, the end user comes in here and it goes to this line number 1, the first route, which is where you upload your items here, and then the content becomes available through the CDN to the other users in line number 2. In the other scenario, which is here, a live stream source is the case when we do what I would call a Google Hangout on air, where you're doing live streaming, and that live stream itself is fed in form of Adobe's Flash Media Server that is available on Amazon. There are other products just like this called Wowza is another one. This product, Wowza Server, is a media streaming server solution available. Then we have Adobe Flash Media Server is available for streaming videos from Adobe as a company. They provide you instances in the Amazon cloud for streaming of videos that you see a live streaming example. So when President Obama will do his State of the Union speech, he will actually go on YouTube and do the streaming on YouTube live, and that becomes a source. So he becomes a source when he's speaking live and doing State of the Union speeches. That stream from his cameras is fed into Adobe Flash Media Server instances in the Amazon cloud, which is this software here. And that is available on the Amazon Web Services. And you can get that from this button. It goes straight to the Amazon cloud, and you can continue. And here you get to see the pricing that includes the Adobe Media Server extended in the machine itself. So all you need to do is just select the right size of instance and then start streaming if you like. Now that's one choice. The other choice is available is this Wowza Media Server, but the best one is actually none of these two. The best one is an open source solution, and that solution is called Red 5. And this is a open source solution that competes with competes with Adobe and Wowza and everybody else. And it is entirely open source, meaning it will do all the formats that you want and will stream it for you, including the RTMP, which are Adobe protocols, RTMP, RTMP-T, and RTMP-S, and even HLS, which is HTTP live streaming for your Apple devices. So it is doing all the possible streaming solutions available, and looks like it's a new site for them because these guys are having fun apparently. And but the source code is old. It's established, so it's fairly well established software that you can get through from here. And so that software is quite useful. And so you can get the download from here and install and use it. It's available for Windows, Mac, and Windows installer, and there is a Unix binary also, Unix compatible source code also. So you can get the source from here and party all along. It's Java based, so it basically runs anywhere Java runs. So that's the streaming solution that you can put together to enable a live stream feed into a solution that the end users can watch. So if you go to YouTube live streaming, and you can watch some things that are happening live right now. And these are the events that I did a while ago, and that these are the things that did not record successfully. And the others get converted into a real live event. So you can see that the videos that we used to do before is showing up here in the list. Now, having said that, if you go to YouTube itself, you'll be able to find some live shows happening right there, right now. How do you find the live shows? Do you know how to find the live shows? I cannot seem to quickly find it. Hmm.
No, I don't.
Nope, I've never watched that.
Yeah, so okay, I think it's called Hangout on Air these days. The name is changed. The name is Hangout on Air, and they may be happening already. On air. See who's on air. So this Conan. Is he doing a live stream right now? I don't think so.
I
So
think there was a button that said live streaming.
where was that? Oh, sorry. Oops.
It was right under where it said Google or Hangouts on Air.
Let's go there again. Yeah. So here are these things that are happening live right now, and we can watch whoever this guy is, Kaiju Fun. And you can watch them live, and they are streaming right
I
now.
saw that at Target had
I think these are kids.
everything.
Yeah, these are kids doing some random talk. I don't know what they're doing, but essentially they are streaming live, just like this, and they're streaming through and through to the end user, which is us right now. We were able to watch their desktop as they were streaming something to do. I don't know what was that, but whatever that was, essentially was a live streaming coming from their computers into YouTube, where we are able to watch it. And so that's this pipe at the bottom, this segment where you see live streaming using Adobe Flash Media Server instances, and Amazon CloudFront also has the live streaming distribution. So if you recall that discussion, you will have a reference to Amazon CloudFront, which is here. And when you try to create a distribution, they're giving you two choices. One is a web distribution, and the other one is the RTMP distribution, which is for CloudFront live streaming. So I think you tried this option first, but if you go this option, you can create a CloudFront live streaming. Sorry, to create a RTMP distribution, you need to have that method used, which is the RTMP based, and the files need to be sitting in the Amazon bucket correspondingly, and then you can use the RTMP protocol, which is using Adobe Flash Media Server to transmit. Now back on on this chart, like this chart, as you saw, there are other charts on this, and so what I was saying is that each one of us, if you can take 2 or 3 of these and study them, and when we meet the time after next, which is maybe Wednesday, or anytime you feel comfortable and ready, I would like you to take up, let's say, e-commerce as an example. What would it take to build out an e-commerce solution, something like Amazon.com, on Amazon Web Services? So this is like a store that you sell products and goods on Amazon. Sorry, I confused you. What I'm saying is you can create a e-commerce store on top of Amazon Web Services, something like Amazon.com running on top of AWS. So that is what you see in this illustration, where you have this illustration. Where is that? Yeah, in this illustration, where you have the example of what would it take to build a complete e-commerce website. Part number 1, what does it take to build the front end of it? And then there are 3 parts to it. And there is this part number 2, the checkout pipeline, and part number 3, marketing and recommendations. And so these 3 parts, the recommendations are the same thing that you saw probably the last time I spoke about it, which was people who bought this also bought. So if you buy the gold book, people who bought the gold book also bought the other book. It's not luck. or people who bought this book also bought the critical chain book. And so that is the recommendation engine that you have. How do you build it out together is the third section here. Similarly, there are examples of how would financial services industry apply grid computing concepts, or online gaming industry will build your silly game that they have on Facebook. What is it called? The farming something game. Yeah. So how do you build that farming game on Facebook? Is this illustration, and there are more such examples. So what I would like you to do is pick two or pick three and study them on your own and discuss with other people next time or the time after next when we meet. Are you game for that?
Yeah.
Yeah.
Hoorah. Hell yeah.
Yep. So yeah, so please do that. And what I'm suggesting is in Slack chat. What was that? Liquid Stream Mystery Cats. Okay. Great Danes Indoor Puppy Room Service Dog. So yeah, thank you. And so what I'm suggesting is here in chat, please select 3 of these, and the next time, time after next when we meet, that we talk about these things and we go over them. But I think it is important for us to look at these on our own, bring our thoughts together, and as you will take turns in describing what you have in these references, reference charts, I will supplement that and expand on what you are discussing with giving you specific examples of every different industry type. And I'll just quickly go through where these industries come from. So here is a typical example scenario, which is web hosting. This is in simple illustration of this would be somebody who is providing web hosting services to other people, such as the example that Jared is using. Jared has set up a website based on this company's hosting plans. And Jared's website, if I may show everybody, is this. So he has put together this site for some items he wants to sell, and so he wants to sell these things that somebody, I think his dad creates them by hand. These are artwork his dad creates, and so he wants to sell these things, and people will buy it, of course. These are beautiful items. And so he's creating a shopping cart based on what he's doing. And so he has put his dad's name and email. And so he's.
Yeah, it's not completely finished yet.
Yeah,
It's a
it's
start.
work in progress. I'm just showing you an illustrative example of what that thing essentially is in here, is that this is a representation of how WP Engine would build. Right? How would they build out their own infrastructure on top of Amazon, as an example, where this company comes into play. Another one will be this Bluehost, another company. They will give you this $3.50 per month, free free this, free that, and so
unlimited bandwidth. What about storage? That's cheap.
Unlimited storage also.
Holy cow, $3.50 a month.
Yeah, but don't get enticed by that promise. That promise is, although it is valid, but this promise is it comes at a cost.
Aha.
The cost is slow performance.
Oh.
Yeah, they don't say anything about performance here.
No, they don't.
Right, they can give you unlimited capacity, but at a very slow speed. What's the point? What's the point? Right. So that's how the catch is. Sometimes, by the way, Bluehost is okay, and even there's this other company called DreamHost. They are competing with Bluehost, and so DreamHost.com, again, your hosting solutions are available. Choose a hosting plan, and the pricing here is $8.95 per month. But just try searching for, if you want to go to DreamHost, you go to Google and then you should search for Bluehost coupon, and that's how you will find DreamHost coupon. And so if you want to go DreamHost, you will search Bluehost coupon, and if you want to go Bluehost, you will search DreamHost coupon. And so they are very good competitors, and so they look for each other's keywords and entice you to join them.
Could you look at if you go to Slack? I dropped a link in there for gen.xyz.
Okay, gen.xyz. Let's see what that thing is. Gen.xyz. So is it another for every website everywhere?
Mm-hmm.
Featured XYZ websites.
Yeah, click on resources, and there's a pricing drop down. Pretty flat. They seem to be pulling in a lot of students who, well, like Washington Tech College, for example, after they've done their hard work with their HTML, HTML5, CSS courses, and what's his name, Dave Dion, teaches the HTML course, CSS course there. He's just switched over his hosting because he didn't like how they treated him or something. Anyway, a lot of his students were starting to lose their websites. They want to keep them, so he points them to here.
Yeah, and so for like this, it's a very, very decent looking service, but I always worry about the low price. This low price may not be really the price you pay, because you might end up paying in performance. Like these guys, they look good and they're all okay for the first few months. But over time, your machines and your servers will become slow because they put you on a shared host. And that concept is what is described. It's a shared host. And it is not like an isolated VM just for you. There's no such thing here. It's not a VM. It's a shared host where other people are sitting on the same host, and that becomes a problem over time. And so that's what you need to worry about when you are dealing with these companies like this. And so that is a factor you should also look at when you're looking at pricing like this.
Right.
$3.50.
And that $3.50 is an introductory price. That's the come-in sucker. And then it goes to regular after whatever you do, a year or whatever.
Yeah, in fact, you can sign up for a long-term commitment with them and stick to the price for 3 years. That should be a possibility.
Yeah. And then find that your website's based on optical disk.
Yeah. Optical. Well, as soon as somebody hits the www, somebody will have to go and fetch the CD and load it up. Is that the idea?
It's all done by drones. Little drones flying around retrieving disks.
Yeah. So there is a Indian name, and the name is called a drone. I think you will, Kiran will appreciate that. There's a word called Dronacharya.
Okay.
So this Dronacharya is a historical person. It's mythological person, I think. And so the idea is that he is the Acharya of drones. So we knew drone technology many, many years ago, 5,000 years ago, apparently. That's what India claims when it comes to drones. So having said, the having here.
There's a College of Engineering for that too, isn't there? Dronacharya?
Yes, there is a College of Engineering also. How do you know these things, man? There is a Dronacharya College of Engineering, true. And so they are into drone manufacturing, apparently. Yes, you're right. It is indeed a College of Engineering. So this illustration diagram is about people like Bluehost, DreamHost, and WP Engine that are providing services as a web hosting application that might run on the Amazon cloud, as an example. Now here we just discussed this one, which is content and media sharing. So you have user generated content, you supply that, and you also consume that. We already discussed this. We have other here examples of batch processing. We kind of sort of mentioned it, but then there are several things that you need to read. And then the best way to read these charts are actually these numbers 1, 2, 3, 4 at the bottom. They describe it nicely. And there is a bent, there is a slight bent to favor Amazon Web Services. They will use Amazon lingo and they will tend to favor and show everything in a light that makes Amazon look good. And that you have to understand that it is their marketing material. And so, having understood that part, you need to remove the marketing elements out of it, which I'll help you do that. And then look at the merits. The reason I study these charts essentially is because they're nicely done, even though they contain a bit of marketing involved. Every time there is a reference to Amazon something, Amazon this, Amazon that, and Amazon this. So the idea that I want to make use of these things is that doesn't have to be Amazon. It can be other people's solution also. And you can pull together a complete solution just like you want with some effort from other providers as well. The bottom line is to understand what these guys do and how they are recommending to implement, in this example, a batch processing scenario. And this is how they suggest that you would do. And this is their reference implementation that they are suggesting that anybody who is interested in doing a batch processing application will deploy resources like this. Next we have is this fault tolerance and high availability. And that is a very common scenario in most big businesses. The idea here is in fault tolerance and high availability is that you have a data center already and it is in-house. But then you worry about something going wrong. And so you want your people to continue to use and access your services, even though the things are all broken. And so the people should have some kind of a high availability solution. Meaning, if you're a critical business and you have your data center in-house, that you should also have another data center just in case.
Yeah, the disaster recovery site, the bunker.
Yes, just in case this one goes down, that our people should continue to work, accessing here, accessing there. And so you will be able to create a scenario for high availability and fault tolerance using that blueprint described here. So when you read that, you will get a little bit more detail about what they are really trying to say. And I think those application scenarios are important for us to discuss in terms of a variety of different application types. How would you take them and deploy them in a cloud scenario? So here is another one. Large scale processing and huge data sets. When you have really large amount of data coming in from a variety of sources, how would you go about managing them is what this chart tries to describe. Next up is for advertisement serving. So here we have, the concept of Bing ads. What Bing ads is doing is making money, or at least trying to make money on advertisements using Bing as the search engine. It doesn't seem to work. The other one is Google ads, which is very nice. You can actually pay money to Google and they will advertise it for you. And so coffee shop in New York will automatically pull up here. In fact, if you search Cloud Genius, you'll automatically, oh, it did not come this time, but usually I see a Microsoft advertisement right on top, which is crazy. But yeah, I don't care. Now, having said that, the advertisement serving, how do you actually serve an advertisement on a page that either a search result page or a banner advertisement page or some other types of advertising that might exist. And so how do you pull through that infrastructure in a cloud context to enable advertisement business? An example was Bing ads, Google ads, Yahoo ads, Facebook ads, LinkedIn ads, and goes on and on. How do you pull that together in the context of ad serving was this one. The other one here is disaster recovery for local applications, meaning you have on your campus an Oracle database. This is not about high availability, it is about disaster recovery. Is that you may not have high availability, but when things go wrong, at least you have a way to recover from the mess, is what this thing is talking about. It is not about HA. The high availability scenario is different. This scenario we have here, fault tolerance and high availability scenario, is different. It is different in the sense that fault tolerance and high availability means that it automatically fails over, and so your end user never has to worry about what just happened. It just works. It keeps on working for them. Whereas in the case of disaster recovery for local applications that you might have, say for example this Oracle database or some other machines, in fact in your corporate data center, which is the lower segment here, is the corporate data center you have here. If that thing goes down, you will have downtime, and that's okay. As long as it is okay to have a method of recovering from the disaster, and so you can recover that in how they are describing in this sheet of paper, which is to be able to look at what would it take to recover from a disaster that might happen in your data center here. So if something goes wrong in your DC, you have a fallback method to recover from and keep on working after some downtime. And so your local applications that are working already, if they break for some reason, you can switch over to another solution that they're describing here in this sheet of paper. Next up is this concept of file synchronization. Now, in this scenario, the concept is kind of sort of similar to what you would know as Dropbox. You know Dropbox, do you? You use this service already.
Yes.
Yep.
And so Dropbox is a service, it's pretty darn useful. And so what it does is synchronizes your files with, you can share it and give links out and do fancy stuff. And so you can enable a Dropbox-like setup, a file synchronization setup, a file synchronization service for yourself on the cloud using this blueprint. So in this blueprint, I would like you to read this and then come and discuss when we meet next time or time after that, whenever you feel ready. But I want you to do that because this will help you clarify your thought, clarify your understanding on a variety of different types of application sets that you can then take to any cloud. It doesn't have to be Amazon Cloud. The only reason we are looking at Amazon Cloud is because they have put together a very easy to use and easy to digest collection of diagrams that helps us in comprehending how would we take on a different type of application like these or like media sharing. So this is another case where you have a person who is creating content and sharing it with other people. So this is also similar to YouTube in some sense, except in here there is other activity also happening, which is there is a encoding process that you can actually put together in the concept of spot instances. You see number 4, And that number 4 is an indicator that you should use spot instances in that segment when you are processing the incoming videos or incoming content. So this user that is sending this content over through your load balancer and upload them over to some kind of a storage here in the middle. That storage has to be handled and processed in encoded, and that encoding has to be done, and for that you put in a queue, and the queue will then get collecting items get collected in the queue, and then you will deploy spot instances that will act on the queue to reduce the queue height or a queue length. So if you have items collecting, let me describe this a little better. So you have a list of video number 1, video number 2, video number 3. People are uploading these videos over to you, and you need to be able to encode them. So you need to put them in some S3 bucket, but then you also create a queue, and in that queue you will put in a list. In that bucket you have these 3 videos, good, but then the queue has to have an action called process v1, process v2, process v3, and that's the queue being built up. And so queue will build up over time, and somebody has to deal with this processing part, the encoding part. So encoding has to be done, and the encoding has to be done by some spot instances. And so these spot instances will then kick in and take the item from the queue. So they'll take this item first. So okay, I have taken that item. Your queue is now shorter, only 2 items in there, and I'm doing the process v1 right now. And then when it is done processing, I will produce, basically I'll take from S3 this v1 and then produce the processed v1 and put it back in S3. And then my processing is done. Then I will take the next spot instance, or have the existing spot instance deal with the next item in the queue, which is here. So I need to get that process v2, for which I need to go grab the v2 item from S3 and then process it to create a processed v2 and put it back in S3. And then I'm done processing v2. So I'll go mark the queue as only 1 item left, and then I'll go process v3. Then I'll have the spot machine process v3. So it will get the item from S3 and then process it to create processed v3 and put that back in S3. So now in S3, we initially had v1, v2, v3, and at the end of the queue has process v1, process v2, process v3, and the processing finished. Now we have p1, pv1, pv2, pv3 also, and all these items sitting in the bucket. And that was able to be done through spot instances that were able to do encoding for us. And that is what they're trying to show you in this sheet of paper here. The spot instances and the queue essentially is responsible for keeping track of what needs to be done, and these spot instances will do it. And doing meaning you take from the media repository, process them, put it back in the media repository in the middle, which is this media repository, which is essentially S3 bucket. And that's how they are trying to illustrate this concept of media sharing, which probably better aligns with your Netflix example, where you have a bunch of queue of items coming in from the media industry. The movie industry is giving you raw files here in this segment here, and they all get uploaded on the back office. Somebody inside Netflix in the company is putting them, uploading into the web servers, and they all go into the bucket here like this. And then correspondingly, an entry in the queue will be formed that, hey, process this new movie called Spy coming up. Boom, that process item will get entered in the queue. And then you have to start spot instances that will process and create a processing pipeline. In here, you can put an auto scaling group. And so that's the illustration that I have. I would like you to read this, and I'll further elaborate on these aspects when we discuss these things again. Next up, we have online gaming, which is like, what was the name of the game again? Farmville. Yeah. So how do you play Farmville? you cannot view Farmville because you have blocked it. Of course, I have blocked it. So I cannot view Farmville myself. But Farmville apparently is a game that you may have heard of. I'm sure you may have heard of it. You must have blocked it yourself also. But that idiotic game is, I don't know what you do, but you do something, some silly things. And so in that silly game, people play. And I have seen Microsoft employees play the stupid game full time during office hours. And that is mind boggling. And so that's what this online game is. And this is the architecture laid out to create a Farmville for yourself. Next, I used to get invitations from people asking me to play Farmville with them. And that's when I ended up blocking it. And so that's what you see. You cannot view Farmville because you blocked it. So, yeah, I used to get like water my something or feed my cow. Those requests used to come. So, do you recall those Farmville things coming to you?
Never played it.
Yeah, I know you never played it, but did you at least receive the request from your friends?
Oh yeah, yeah.
Yeah.
Just ignored it.
I know, I blocked it a while ago. So that architecture you see is actually about how do you pull together online gaming. And like this, there are other types of games available on the internet, such as the good one is called LOL, League of Legends. Yeah, this is a good company that created Burkshelf. So you know Burkshelf is created by these guys, Riot Games.
Good grief.
You know this software is created by and maintained by the Burkshelf core team, and this guy Jamie Windsor works for Riot Games. Where is Jamie? And so this is the guy who is now a software engineer at Undead Labs.
Jeez.
Wow, he was previously at Riot Games. So now he's with a different company, Undead. Nice. So he created Burkshell for us, and so that's a gaming company, and they are big into using the cloud to enable game scenarios. And so that's another example of another gaming company. And this is an example implementation of how would a gaming company create and pull together a game that you can play and that people can play on mygame.com, like here. My game. There's no such thing, by the way, but they're just illustrative examples of how a game would be implemented online in the cloud. Next up, we have log analysis. And so do you know what a log is and how and why would you analyze it? So this
It's going to
guy,
record both sides of a transaction, both sides of something occurring, or maybe one sided of it.
yeah. So
Seeing
this,
there errors like failed to connect or something like that.
yeah, makes sense. Totally.
I know, Niku.
So this guy is doing log analysis at Expedia.
Yeah.
And so what kind of logs do they collect? So if you go to expedia.com, okay, they just collected a log entry from me that somebody visited you. Somebody visited expedia.com just now. That's what they did. So they know that I am visiting from my IP address. And so if I search for something, say go to from Seattle to Mumbai, and search. And so now they have another log entry. And so they know that I'm interested. And so that accumulation happens in a log file that looks something like this. You see these logs coming up from my server that runs your aws.cloudgenie.us site. So these logs are actually getting created. Let me show you side by side so you can get a good perspective on what logs are and how are they relevant. And so here is the logs coming in, and here is the site that you know and use. And so here, just start browsing and you will see that logs are accumulating. It will actually say that Nilesh just logged in. Somewhere along the way, you will see that these logs are actually showing. So if I see the course, it is generating some entries, and some log entries are happening along. So somebody needs to go and analyze these logs, and that is what that person does for Expedia. And so the Niku that you saw is doing that exact thing in Expedia, where he's looking at the operations and traffic coming onto Expedia and finding out what's going on and how do we make sense out of it. So having described that idea, this is the infrastructure that is conceptually there for Expedia for them to understand and analyze the logs that they collect. And the log files come from a variety of places, and they collect them, they analyze them. And so this is Niku. He sits here and looks at the logs themselves. And this is the analytics database. And this is a Hadoop cluster. That's what this other guy runs, which you probably have heard of. This guy, not this guy. This gentleman runs the Hadoop cluster. This gentleman, this guy. He is the director of technology at Expedia, and this gentleman runs.
Hi, I'm Murugan, and I work with Microsoft in the cloud with.
So this gentleman runs the Hadoop cluster, and what they are doing essentially is analyzing logs coming from a variety of web servers that Expedia runs. And people like us visit their sites, so the machines will generate logs. They will collect the log files, put them in S3, and then analyze them in a Hadoop cluster and put them in the analytics database. So I would like you to study that in that context, so as to give your thought behind what would the case be for a company, an example, an illustrative example that you will then apply and understand. What would it take to put together a log analysis application on the Amazon cloud or some other cloud. Here is another one, is financial services industry, where they're doing grid computing, meaning they want to do their trading applications, for example, or other types of financial applications that they may be running in banking industry in New York. What would it take for them to pull together a solution is what is illustrated in this illustration. Next, we have the e-commerce examples in three parts: front end, the checkout process, and the marketing and recommendations engine. So it's very, very intense in terms of how they are describing. In most common scenarios, you don't have to go all that route. You can set up very, very simple, trivial solutions available out there that are easy to set up an e-commerce shopping cart. It doesn't have to be this complex, but this is their representation of how one can do. And then there is this time series processing. which is another concept where you are essentially storing. By the way, do you know what a time series essentially is? What is time series?
No, don't know it.
Okay, so time series is a representation of some collection of data, and then you do it daily, and you keep track of day number 1, day number 2, day number 3, day number 365, year after year. Keep track of what the data is for every type of metric that you want to accumulate and collect, almost on a daily, or even some companies go to the extent of hourly or by minute and by second. So by minute or by second, if you collect data and snapshots of this data that you want to collect, of some metrics that you want to have and that you want to worry about, and you put that in form of a series, that's what time series is.
Ah.
What does that mean? It means that a simple example will be stock price. Stock price changes over time, second by second, every day. And so then you have this day number 1, day number 2, and goes on till day 365. And then the next year starts. And that is an illustration of what a stock price as a time series is. So it's a representation of some data over time. That was just one data point, the price of the stock. And so the Apple stock price, for example, you can put numbers around it and put it, how did it change, and you see that representation of that time series in here. Sorry, not here, but here. So you see the representation over the last year. This is how the chart was, and you can see how it has changed over the many years that it has been in place. And so over the last few days, it has been going down a little bit. And over the last 5 days, it has gone down from 131 to 128. So you can see this representation of data is time series. Similar to that, you can collect statistics about just about any type of data that you want and analyze them. Examples of that would include, sensor data collected from gas pipeline companies, electricity companies, utility companies. They have so many things to collect, and they have to keep track of these things day by day, hour by hour, minute by minute sometimes, in terms of what would it take to keep track of how things are going, because they are responsible and answerable to their customers or their management. So they need to keep track of these things in form of a time series in what is known as a data warehouse. And so it is essentially structured data that you would store in some kind of a warehouse or some place to store stuff, some place to store structured data. And if you store that in a time series fashion, that is what this illustration is trying to describe. And in here, they are also looking at this Amazon Redshift. And Redshift is a service from Amazon that is responsible for large scale data warehouse. So petabyte scale data warehouse is this service. And what they are suggesting through this service is that you can run, do not appear to have any clusters, I know that. Yeah. So if you basically launch a cluster, essentially what you're collecting and creating is a very large scale database that will store information and also take care of time series, so time dependent information about what it means to store. Like in this example you see here, SCADA, which is a method of data acquisition, supervisory control and data acquisition, which will provide you time-based information about something that you are trying to measure. And you collect that and you process that and you store that for future usage from your analysts. So over time, how did things change? How did the temperature, the pressure, the weather of this situation changed? How did the market change in terms of pricing? What, any other metrics that you want to measure and keep that record over time, you would want to keep that in some data warehouse and apply business intelligence principles on top so that your analysts who are trying to make sense of how things were before and how are they now can make sense out of that, is what this illustration is trying to describe. And here is your little business intelligence user, the end user of this data, who's going to infer from Amazon Redshift, which is again your database warehouse, data warehouse. And through that warehouse, it is going to infer, trying to extract meaning out of what that data is trying to tell this user as to what does that data mean. Of course, you can collect any amount of data that you want, and keep track of all historical data minute by minute, second by second on a large variety of metric. But unless you can extract some meaningful, actionable insights out of that data, the data itself is pretty pointless. And that is what this particular illustration is trying to describe to you, is in the context of what is illustrated as how would you implement a time series processing scenario in the cloud. And their focus is the Amazon cloud, which is understood. We are just using their charts. We are trying to understand the concepts from here as to how will they apply to a general purpose scenario. And they will use Amazon Redshift. We'll use our own database. It doesn't have to be Redshift. We can use our own data warehouse solutions. It doesn't have to be them. Here they're using Elastic MapReduce, using EC2 Spot instances, and we can use our own Hadoop implementation either on Amazon or some other machine can also run Hadoop, because Hadoop is open source, and that is what this thing is. Elastic MapReduce is essentially running Hadoop solution, and Hadoop is an open source product available at this site. And so that is what they're running in that big box, gigantic box here. There's a cluster of servers running this software. And I think that is the last item in the list. So in this context, what I'm really asking you to do is to study these example reference architectures that they have provided us for actually their customers to consume. And they are giving examples of how you would use the Amazon cloud in a variety of different scenarios, which I think is a very good way of looking at different types of problems. Like we have been studying this Netflix media sharing thing for the last 2 occasions, where we are studying about how the user will, watch what they're doing and watch whatever movies they want to watch. And the internal Netflix users will be uploading their movies and processing them and making it available for the end user to watch. And so that application, as an example, applies to this particular sheet of paper. But then there are other industries and other use cases where you can take these to the cloud. And here is a listing of illustrations that are describing to you how would you do that. And so that's the reason why I ask you to take up 3 of these maybe. I think we can take 3. How many? 1, 2, 3, 4, 5, 6, 7. Yeah, we can take 3 each. So take 3 in the Slack chat, and please name. Please name 3 of these that you would like to select, and let us meet next time when we do. And in that time, I would like you to describe what these actually mean to you from your perspective, and I'll supplement that discussion from my side, and we'll do that. Now, on the last time we met, we said that we will do some monitoring and metrics, and you might have had a New Relic account and a WordPress account, sorry, not a WordPress account, but a WordPress machine ready. And so you need, for the next time, what I want to be able to do is run some monitoring applications. I want to monitor two things broadly. One is a server. How is the machine itself doing? And the other one that I want to monitor is the application. How is the application doing? App performance. In case of server, I want to monitor CPU consumption, memory consumption, disk consumption, network consumption. So these metrics I want to monitor and understand what it means from a machine health perspective, and also from the application's performance perspective. I want to be able to monitor. And so to do that, two things, we need at least one server and at least one application. And so with that in mind, I'm suggesting that we use DigitalOcean, for which you still have some coupon money left over, and use the WordPress application and then configure it, all this, to work with New Relic, for which you have an account for free and a t-shirt if you like. But t-shirt is optional. T-shirt is totally optional. You don't have to get it. What we want to do with this setup essentially is the two things that I mentioned, which is measure infrastructure performance. Infrastructure, which is, you deal with server, your CPU, your memory, your hard disk, your network. Well, how are they doing? How are they throttling? Is it performing nicely? That's what we want to measure. And at the second layer, we want to measure the application performance. How does the application run? How is the user experience index? There's a thing called AppDex. You have to study that and understand what it means to measuring performance of an application. So just one application and one machine is what we need. And so that is what I would expect you to do, and be ready next time we meet, which is Monday. Is it Monday?
Yes, it is.
Yeah. So next time we meet Monday, just before that, if you can put a machine together with WordPress on a droplet running, that will help us move faster. And you have a New Relic account already. So we'll put these things together and start some monitoring, which is a important aspect for us to understand user performance. How is the performance for the user, and how does one go about monitoring them? And then we'll go play with some other tools in the open source domain that also help with the same scenario of monitoring. And then on the next time, which is after Monday, so Monday we do the monitoring part. On Wednesday, I would like you to pick up your topics 1, 2, and 3 out of those sheets and discuss them right here in our go-to meeting.
All right.
And make those selections. So name your selection. If somebody else named it already, you cannot take that name, of course. So name it faster than others if you want a particular topic.
Yeah.
And name that in group chat.
All right. Sounds good.
Got it.
Cool.
Cool.
Okay. Got a lot of homework this weekend.
Oh. Yeah.
Lot of homework.
All right, I've got some homework. Nilesh, I'm going to sign off. I'm going to get to bed early. It's been a long week. Gentlemen,
Makes sense.
have a safe weekend. Talk to you all on Monday.
Yes,
All right,
sir.
Chris. See you, pal.
All right.
And safe
Yep.
travels.
Very good.
Have a good
All right,
weekend.
guys.
Safe travels.
See you guys.